Again, Mark Palmer and the city engineer, City of Puyallup, and we're going to go specifically over the design parameters on porous asphalt. Again, we'll go over the material specifications, specifically what we need to have in there for porous asphalt. We'll go over some of the performance parameters of permeable asphalt. Just a brief mention of green technology using warm mix asphalt basically, and then if there's any time for questions, we'll go over those at that time. And porous asphalt, a lot of these design and performance goals are common to a lot of the other porous pavements, but the one I want to highlight here is providing the durable, long-lasting wearing course for asphalt. That seems to be one of the issues that we have with permeable asphalt, porous asphalt. And finding that balance between the porosity of the pavement that we're trying to get so we can have the water flowing through the pavement and still having a durable surface that doesn't ravel or have other issues of rutting is one of the balances we're trying to find with mixed design. As Curtis mentioned, mixed design on porous asphalt's been a moving target, continues to be a moving target, and you're going to see information today that's only been presented one other time before as an example of how this keeps moving. And in general, everybody's been pretty accepting of porous asphalt being a good use for roads, our local roads, trails, parking lots. But we do have an example here that's shown in Arizona where we do have a fairly high volume highway that's being used with porous asphalt. There's some other examples in Texas and some other places where they have porous asphalt on high volume roads. So it has been used for that as well. And just as a note here, this is some of the report that was done on this particular road at the 5-year point that they were maintaining the porosity that they had for design 5 years into the project. And it was operating satisfactorily at a 20-year point. I don't know what it's been doing subsequent to that, but it was operational. And if you notice on this picture also, there is very little visual difference between either side of this road. And one side is regular HMA and the other side is porous. One of the things that everybody wants to use porous asphalt for low-speed applications, i.e. parking lots, and that tends to be one of the toughest applications that we have, again, because of those low-speed turning motions. If you've been in a parking lot, you've seen regular asphalt has a tendency to ravel a little bit. Porous asphalt just a little bit more so. Some of the things we'll discuss here in the design process will help reduce that effect. Chris already mentioned the resisting the temptation to mix porous pavements and dense graded pavements, and I totally agree with his opinion on that. We want to try to restrict that as much as possible. If you do have transitions, do that at the crown or find other ways to intercept that impermeable flow so you're not clogging your pavement. One of the things to keep in mind with porous asphalt that makes it different, and I'll be comparing and contrasting a lot here to pervious concrete. Pervious concrete, being a rigid pavement, has a totally different design concept than porous asphalt and all the other permeable pavements as flexible pavements. When you get to high volume roads and you're already doing the assumption that you have a basically poor saturated subbase, you're designing conservatively in order to bridge that subbase. So basically your pavement sections will get thicker and thicker with porous asphalt, and that goes up almost exponentially as you start talking about heavy truck loading, heavy volume loads. So on arterial roads, porous asphalt can become somewhat less cost effective, especially when you consider it as a life cycle cost versus pervious concrete. So those are things you'll want to think about when you do your treatment or your design for pavements. And again, for example, the City of Puyallup, we're basically where we can, if we're doing porous pavements on arterial roads, we're going pervious concrete on that, and then on local roads or other low volume roads, we'll use porous asphalt. But to thin the section, if you want to, you can use GeoGrid or do a permeable treated asphalt base, and those both have advantages of adding structural strength to the section. The porous asphalt treated base actually has the advantage of removing the choker course, which has been a traditional part of porous asphalt design for many years, and gives you a much more stable base to work on with your paving machines. And that's a critical thing. You're getting two benefits out of that. You're getting a more stable paving surface, and you're also getting structural strength out of it. So that's another way to thin your section down somewhat on porous asphalt sections. And just an example, this is a section taken from our WSU frontage project. We're working with WSU Puyallup to do some more experiments on water quality treatment. As Curtis mentioned, we're trying to determine or confirm that water quality treatment does occur within the pavement section itself. This particular portion of this project will have some additional testing to supplement what's going on at the WSU LID site in Puyallup. But on this, we also had geogrid on this. And the reason, this is an arterial road, and we're not using pervious concrete on this particular site, primarily because we have about a 4 or 5 foot layer of peat about 10 feet down on this. And with that kind of a surface underneath there, which will be a lot of differential sediment, we didn't want to put a rigid pavement on top of that. So we will be using porous asphalt for this particular section where we have that peat condition deep down underneath. And you want to check with your geogrid manufacturer as far as placement of where that is. It's typically you want to be up higher in your pavement section so it has a better chance of spreading that load out over that weakened subbase. But that can be anywhere within your reservoir course. So another compare and contrast between porous asphalt, pervious concrete. One thing I like to keep emphasizing is basically once you got your mix design right on porous asphalt, any paver you got out there can go and install it. It really is no different, other than a couple little minor differences, than any other standard HMA pavement out there. Once you get to that point, you're pretty well set. The disadvantage we have is porous asphalt, at least now when it's the exception rather than the norm, is you're really not going to get porous asphalt in small batches. So when people come up to you and want to do a driveway with it, you're probably not going to be able to do it in porous asphalt unless they can tack on to a big run of another project somewhere else. Batch plants, I've been told many of them 40 tons, 50 tons is about the minimum they would even consider. That's quite a bit of asphalt, and you're probably not going to get that in your driveway unless you got a really, really long driveway. As I already mentioned, high volume roads could be more advantageous to do pervious concrete, and actually we've made that determination in the city. So on high volume roads, you might want to look at the pervious concrete, which again, Chris will be talking about here after me. One thing when we are working on arterials, and the one we're looking on at the city of Puyallup is 39th Avenue Southwest, which happens to run right in front of our Costco. They're not really going to be too excited about having that road shut down for 7 days while we try to let that concrete cure and have that plastic covering on it. So intersections on that particular project will be dense graded high early concrete, so we can actually get that poured and get it back open within a couple of days instead of the 7-day period, so we don't shut down Costco and having them scream. And actually that's a big source of revenue for the city, so I think I would probably get a lot of pressure from other places on that as well. So things like that need to be considered when you're looking at the pervious concrete. And again, that thicker section on higher volume than poor soils. Again, on that continuing theme of specifications, there has been a lot of varying opinions on specifications for porous asphalt. Jessica Knickerbocker, City of Tacoma, and a large group of other industry and municipal parties and WashDOT are involved in trying to develop a standard specification that everybody that's doing municipal work and uses WashDOT specification can put into their specs and use with confidence. That's getting closer. We're inching forward and getting closer on that, and hope to have that out here in the next couple of months. We actually had hoped to have that out by the time we had the Stormwater conference last week, but that didn't happen. So now getting into specifics for asphalt materials. And we had a mention of raveling, and one of those things we want to do is we want to use a 7022 polymer modified asphalt. That's a performance grade asphalt that has just a polymer in it that helps it be stickier. That's the easiest way to think about it. That polymer's making it so that that binder will stick to that aggregate and stay there longer and better. And that's actually a key component. We want to have that in there. You might get some blowback from suppliers on that, particularly if you're in this time of year. It's not necessarily readily available in the November time frame, but you really need to stick to your guns on that one. The next one that we have a lot of debate on still, but based on, and it's just anecdotal evidence that we've had from many different other asphalt, pervious asphalt designers from around the country, is that 6% asphalt tends to be a critical element, and I guarantee you every supplier that's out there will try to get you down below that 6%. But as long as you can do that 6% at your 75 gyrations compaction effort, and you can pass your drain down test and voids test, that's where you need to be. There's a couple things you can do to increase that, and adding fiber would be one of those. Adding actually a little bit of fines to your asphalt mix would also do that. That would thicken the mastic and make it adhere better to the aggregate, so it wouldn't drain down through the mix. Those are things you can do. But generally, again, this is going towards that durability aspect of porous asphalt. We're trying to improve the durability of the pavement, so the actual asphalt content percentage is important. The type of asphalt you're using is also important. As far as the specifications for the aggregate, the Napa, which is the Napa porous asphalt specification, that's a good starting point. Again, work with your local aggregate suppliers to determine if you have aggregate can meet the specification. If not, again, try to find something that meets the intent, that it has an open graded and void content that will allow the asphalt itself to have a void content of somewhere between 15 and 22%. You can also use your aggregate for your asphalt as a choker course as well, and that makes it simpler. If you're specifying one rock, it makes it simpler for you, and that will work as well. And I'm just showing here that you can have different size aggregates to use in your mixes, and they can work. This was one that was specified on a project that I did in Tumwater, and that was successful. It's a little bit smaller aggregate, but it worked out fine. Just need to be careful when you look at those to make sure. As far as using these things on a choker course, and I'll talk about the choker course because that is kind of unique to the porous asphalt section. What you're trying to do with the porous asphalt section on the choker course is, again, give yourself a stable working base. That large reservoir rock is hard to work on with paving machines. It can tend to act like a bunch of marbles, roll around, cause a lot of rutting. So you want to make sure that you have something to set up on those pavers on if you're going to use rock, and this is just one option. This particular case, we had almost everything was in between the 1/2 inch and the 3/8 inch size. That's not a wide range, and we had over 50% of the rock was in there. And when you do that, you don't get a good interlocking, you don't get a good firm base, you actually get something that looks more like that. And that's what happened on that site in Tumwater. So you just got extreme rutting. This is just pickups going across here. This is not dump trucks or anything else. It just, like I said, it was just a bunch of marbles rolling loose. You could actually amend that and put a correct gradation back in and mix it with the rock in place. And we did that in this particular case, and then we were able to solve the rutting issue on there and got a good firm base for that. The caution I have as a designer, if you're looking at this, is to look at your rock when it's submitted and actually put it on a chart similar to this so you can actually see what your specification is and see where your rock is lying. If I had done this, we wouldn't have had that problem on that particular site. The green is the choker course specification, so the rock should have been falling within that on the sieve test. As you can see, the red line is what we actually received, and it just went way out of spec and just dropped off the face there. It just, again, that's indication it was pretty much all one size. The contractor came back with something that was a slightly larger aggregate, but basically had the same gradation curve, same shape and slope, and that one actually worked very well, even though it wasn't exactly what we were looking for. So look carefully at your materials when you're specifying it. So as far as the mix design itself, again, you want to be looking at air voids in your mix design at 16 to 25%. I would recommend staying towards the lower end of that. Again, we tend to have excess permeability in the asphalt pavement that we're designing and the concrete pavements and the other ones we have. So I'm more concerned in particular about your durability, your pavement, and trying to get it closer to that 16% rather than the high end of your voids. You're going to have more problems with durability issues than you are with the actual draining of the pavement and rain. Drain down, there is a ASTM test for that, which is listed here. You only want 0.3% maximum on that. Again, noted 15 degrees above the design mix temperature is what you test that at, and I'll show you that in a minute. Oregon Department of Transportation has an alternate test they use, which is more of a Rorschach test. They put the thing on a piece of paper and they pull it back off and they take a look, see how much asphalt actually came onto the paper. And that's a very subjective test. I wouldn't necessarily suggest using that one. And again, just noting that you can add fiber to the mix, and if you do add fiber, it's generally a cellulose fiber for asphalt versus the materials that you'd be adding on pervious concrete. And you should get all these on your mix design that's submitted to you when you're doing your project from your supplier. Just showing you here the drain down test, the ASTM drain down test, and basically what you're doing is you're mixing a batch of that asphalt to those specific quantities that's in the mix design, put it in basically an oversized mixer, put it in the basket that's on the lower left there, put it in the oven, bake it inside this metal, and have it set on the tin, and then you look in the tin to see those little specks is what drained out of the mix. This one did pass, but just barely. So you can see it doesn't take a whole lot of that asphalt mix coming out of this to fail your test. So it's a fairly sensitive test, but it's not necessarily representative of what field conditions are going to be when you actually have your mix out there. So when you're out in the field and you're looking at your trucks coming up to pave, as they dump out into the hopper and pull away, take a look at those trucks beds before they come back down and see if you see a lot of asphalt in the bottom. If you're getting a good amount of asphalt in the bottom of those things, you may have an issue with drain down that you need to address. I mentioned the ODOT test. That's what that looks like, and they have a series of these slides that are anywhere from 10 to 90%, and that's what you're supposed to look at the one you have, look at the pictures they have, and kind of guess which way it is that the percentage is as far as guessing the drain down test on that. Again, that's not necessarily an accepted standard, but that one's out there if you wanted to use that for a test. Anti-stripping, we've had good discussion. I think we have come to agreement with the suppliers here locally. Basically, if your supplier uses anti-strip in his regular HMA pavements, he probably should use it in his pervious or his porous asphalt mix. Again, not exceeding 1% by the weight of the aggregates in that mix. I keep hitting on the 6%. I'm sorry, but that one is important. So again, resist that and try to do some adjustments to your mix design to get it over at least the 6% minimum to keep your asphalt content up there we need to do.